This is Unit 2, Part 3, Metric Conversions. In the United States, we measure things with different units. For distance, we'll use things like inches, which is that distance there. Or if we have 12 inches, it equals a whole foot. If it's a little longer, we use yards, which is 3 feet. And if it's even longer, we use something like miles, which is 5,280 feet. For volume, you're used to things like gallons. For mass, we use pounds. However, most of the rest of the world uses the metric system. Now, to me, the metric system is much better because to convert between different units, all we have to do is move the decimal because it's based on different powers of 10. So the metric system, for our major measurements, distance and size, we're going to use meters, abbreviated small m. For mass, we're going to use grams. Volume, we have liters. Time is seconds. And energy is joules. So we're used to measuring here feet, maybe miles if it's longer, pounds, gallons. Time, we do agree on seconds, so that's great. And we measure our energy in calories. Now, you are familiar with some of these units already because they get interchanged between others, right? You drink a 2 liter of soda, not a gallon of soda, yet you drink a gallon of milk. So you can see that there's some common usage of the different measurement systems in the United States. So here are all of our prefixes, and this is the crux of the metric system. So here in the middle we have our base unit, which is the meters, grams, liters, seconds, or joules, which I discussed previously. So this is going to be in the middle, and I'll just put M for meters. Now, everything to the left, if it has this prefix in front of it, is going to be bigger than a meter. These are our large prefixes. Anything over here is going to be very small and be less than a meter. So you guys might be familiar with kilometers. Kilo, meter, makes a kilometer. We would abbreviate that km. Now, if you've any race that's not a marathon or a half marathon is typically measured in kilometers. So if you've heard of a 3K or a 5K, that means 3,000 or 5,000 meters, and that's a kilometer. So you see this 10 to the third. That's how many meters there are in 1 kilometer. Likewise, if we go to the smaller side of the scale, all of you have heard of centimeters. Prefix centi with the base unit meters. There are 10 to the negative 1, or 10 to the negative 2, or 0.01 centimeters in a meter. And we'd abbreviate that cm. In class, we're going to do an exercise where we attempt to memorize all of the prefixes that go with these powers of 10. Because throughout the year, and then when you move on to physics later, you're going to be using several of these all the time. So rather than have to look them up or remember some mnemonic device to match them up, you'll just remember them because you'll use them so often. So the way we'll use this is use the powers of 10 to convert between different units. So let's go between kilometers and meters first. So if I want to write what equals what, we have kilometers and meters, and some number of kilometers will equal some number of meters. And we have these powers of 10, where kilo means 10 to the third, or 1,000, and our base unit is 10 to the 0, which is just 1. So between kilometers and meters, the easiest way to never mess up the power of 10 is to give the bigger unit the number 1. So between kilometers and meters, kilometers is large, so that will be 1 kilometer. Now, the other unit, in this case the meters, will get the positive power of 10 associated with that. So 10 to the third is 1,000. Therefore, 1 kilometer is 1,000 meters. If you'd done this backwards and said that 1 meter is 1,000 kilometers, you can look at one of the meter sticks in my classroom and realize that that is completely wrong. This is why the bigger unit gets a 1, and that the smaller unit gets the positive power of 10, because this will always end up being a bigger number. So small number, big unit, big number, small unit. It must balance out in order for these to be equal. If you gave both of these, the big number and the big prefix, then this would be a huge number, and then this would be a tiny number, and they would not be equal. Let's look at the other side. All of you should already be familiar with there being 100 centimeters in a meter, just like there are 100 cents in a dollar. But let's look at it using these powers of 10. We'll write meters, we'll write centimeters. Between these two, meter is the base unit, centi is smaller, so we give meter the 1. That's going to equal the positive power of 10. So instead of 10 to the negative 2, we have 10 to the positive 2, and that gives us 100. There are 100 centimeters in a meter. Now, I don't have specific practice problems for metric prefixes because we will use these as conversion factors in our next unit on dimensional analysis. And we'll use it so much there that it makes no point to start here. But for now, familiarize yourself with these positive powers of 10 and these negative powers of 10, knowing which prefix lines up with which power of 10.